Hello geometry students, and welcome to release question number 17 for the California Standards Test for Geometry. It says in parallelogram FGHI, diagonals IG and FH are drawn and intersect at point M. Let's draw a picture where that's the case. I'm going to draw mine kind of a little bit longer and skinnier than I might normally draw a parallelogram, just so that things are really drastic in this parallelogram here. So it's a little easier for us to tell what has to be true, what must be true, and what might not be true. So let's draw in the diagonals here as well. Just connecting those vertices, opposite vertices. Let me try to draw that in a little straighter. I think that'll do. Okay. And it says that IG and FH are the diagonals, so here we'd have F, G, H, and I, and these would be the diagonals then, IG and FH. So does this have to be true? F, G, I, does that have to be an obtuse triangle? F, G, and I, does that have to be the case? Well, in this one it looks like it is the case, but does it have to be the case? Is there a way I could draw it so that it wasn't? So if I did something like this instead, I had this as F, G, H, and I, would that have to be an obtuse triangle? Because remember, I didn't have to draw it like that. So here's a couple of different examples, a couple of different polygons. They have to hold true. It must be true, so it have to be true in both of these. But if I look at that, this is clearly less than 90, this angle, so is this one and this one. So does it have to be an obtuse triangle? No. Angle or triangle HIG, does that have to be acute? Let's look at both of these and see if it holds true in both of them. If it doesn't hold true in one, then we know we have that as not a correct answer. HIG, is that an acute triangle in this one? No, this was drawn kind of large and expanded out just to make that point. So this angle right here would be an obtuse angle, meaning that this would be an obtuse triangle. Clearly this does not have to hold for any parallelogram. Let's see, if triangle FMG, here's your M, this is your midpoint. It would actually represent the midpoint. It doesn't say that here, but it would represent the midpoint of the diagonals intersection. And does that have to be congruent to HMG? So here's FMG, that's this triangle right here. Does that have to be congruent to HMG, this one right here? Well, hopefully you can see from this one that this is clearly not going to be congruent to that. So it's not going to be that one either. So choice C is out of the running. Choice D I think is right. I'm going to circle it, but I still want to double check and make sure that it holds. So GMH, that's this triangle right here, GMH, is congruent to triangle IMF. And so that's the one across vertical angle wise here and here. This, we could prove this is congruent to this. All right, add this in red. This is congruent to this. And I could also say, because it's a parallelogram, that the diagonals bisect each other. This is one way to prove this. I would have side, angle, side, matching up with a side, angle, side here. So you could say, yes, that would be congruent to that. There's other ways to prove that as well, but that's one way that would definitely work. So the only one that has to be true, that must be true, is choice D for number 17.